So guys, we are going to continue our discussion with respect to statistics, and in this video we are going to cover the measure of dispersions. Over here we are going to cover two things. One is variance and the second one is standard deviation. First of all, we are going to focus on variance, and probably this entire video will be related to variance, because remember, if you really want to calculate the variance, there will be calculations for the population data also, for the sample data also. And it is very much important because the variance formula may slightly change with respect to sample data. Okay. So what exactly is measure of dispersion? Okay. So that is what we are going to discuss. So let's consider one simple distribution like this, ages. Okay. Now in this age, I have values like 1, 3, let's consider, let's make this smaller change. So here I'm actually going to consider 2, 2, 3, 3. Okay. So this is my sample data, or this is my data. Suppose I have this specific data. Let's consider that this is the ages 2 list, and here I have 1, 1, 5, 5. So let's calculate 6, 8, 10, 5, 10, 11, 12. Okay. So over here I have 12. Let me do one thing. Let me just make this as 4, 4. I'll tell you why I'm specifically making 4, 4. There's a specific reason behind it. So 4, 4, and here it is 1, 1, 5, 5. Now if I really want to calculate the average, that is the mu. So what I do, I just take up all the numbers, I add it up, and I divide by the total number of elements. So here if I go and calculate 4 plus 4, 8, 10, 10 divided by 4 is nothing but 2.5. Okay. Now similarly, if I go and calculate this mu, okay, over here, you will be able to see that I'll be having 1 plus 1. Okay, sorry, this is 12 divided by 4. I'm extremely sorry. This is 12 divided by 4. So here I'm just going to write it as 3. So here it will be 1 plus 1 plus 5 plus 5 divided by 4, right? So again, here I'm actually going to get 3. Now, one thing that you can note over here is that I had two different distribution. Let's consider this is my distribution 1 and this is my distribution 2, right? Now here I had two different distributions, and when I'm calculating the average of this particular distribution, it is 3, right? Over here you can see the mean is 3. But how can we differentiate these two different distributions? Because see, understand, the elements are completely different that are present inside this. The data points are completely different. If I consider 3 over here you can see that this 5 and 1 are far away from this mean, right? 3, obviously 5 is away from the mean over here, the element 3. Whereas if I compare 4 over here, it is very, very much near to the mean. Similarly, 2 is very much near to the mean. Over here, 1 is a little bit far away from the mean. Right? So what exactly is getting denoted? Over here, it is getting denoted that the spread is more or dispersion is more. Whereas in this particular case, the spread is less, right? So what element, what factor we can actually use to differentiate this two distribution? That is what we are going to discuss, and that is possible by variance and standard deviation. So first of all, I am going to discuss about variance, and we are going to find out what exactly is the formula with respect to variance. And over here also we will be discussing this with respect to population data, that is capital N, and sample data, which is small n. We really need to understand with respect to these two topics. Okay, so if you really want to know the formula is very much simple. So let's consider that if you want to showcase that how do we denote variance in the case of population data, it will be sigma square. Okay, sigma square, this is the notation that is basically used in the case of variance. And here the formula is very much simple. See, I'm going to use I is equal to 1 to capital N for population data. First of all, let's discuss this with respect to population data. Over here, since we really need to find out what is the distance from the mean, right? Because we are trying to find out the entire variance or dispersion, right? So dispersion. So here you will be using x of I minus mu divided by, right, capital N, and here you're going to basically do the squaring. Okay, so this is the basic formula for a population data in order to calculate the variance. Okay, again I'm going to repeat it. It is nothing but, you can see over here, sigma square is equal to summation of I is equal to 1 to capital N x of I minus mu, or you can also write mu minus x of I, because at the end of the day you are doing the squaring of it, and it will be divided by capital N. Capital N is nothing but what is my population size. This is my population size, right? Population size. Okay, now if you really need to understand this, now let's take this simple example and let's do the computation once again. Okay, so suppose I have the same elements. I'm going to take 2, 2, 4, 4 and probably calculate for this two separately. So I have ages 1, which is nothing but 2, 2, 4, 4, and I have ages 2, which is nothing but, what is the elements? 1, 1, 5, 5. I'm going to basically take this two example, 1, 1, 5, 5. Now what I'm going to do over here is that I'm going to calculate this one first of all. Let's see. So first of all, let's consider these are my data points, which I'm going to denote by x of I, which is this one. So my x of I elements are this. So I'm going to just compute this. First of all, let's go and compute mean. Now over here, with respect to this, what is the mean? Okay, so mean over here is nothing but 2 plus 2 plus 4 plus 4 divided by 4, which is nothing but 3, right? Similarly over here, you have for this specific mean, you have 1 plus 1 plus 5 divided by 4. So this we have already done the calculation. It is going to be 3. Okay. Now the next step, let's go and compute this entire formula. Okay. Now first of all, I'm just going to write x of I. So here I have values like 2, 2, 4, 4, and then I'm just going to see the mean. Mean is nothing but, it is going to be 3. For entire thing we're going to use 3. Okay, then x of I minus mu whole square. We are going to do this calculation. So it is nothing but 2 minus 3, which is nothing but minus 1. Minus 1 whole square is 1. Then again this will be 1. 4 minus 3 will be 1. Okay, and finally what I do is that I do the summation of all these things. So if I do the summation of all these things, what it will become? It will actually become 4, right? The total summation will become 4. And when I'm using this summation, there is also something called as divided by n. Now here my n value is actually 4, right? So if I do 4 divided by 4, I'm going to get the value as 1, right? So this 1 is my variance. That is the sigma square for this kind of distribution. Let's verify this once again. See, x of I minus mu whole square, x of I minus mu whole square, 1 plus 1 plus 1. So here you can see 2 minus 3 is 1. 1 square is 1, 1 plus 1. So I'm getting it perfectly right. And here I'm getting the variance square as 1. Okay, perfect. Now let's do the same calculation for this group of elements also. So here, let me use some different colors so that you will be able to distinguish. Otherwise, it will be a problem for you to understand. So x of I have 1, 1, 5, 5. The mean is 3, 3, 3, 3. Then x of I minus mu whole square is 1 minus 3 whole square. It is nothing but 4. 1 minus 3 whole square is nothing but 4. This will also be 4. This will also be 4. Now here, after this what I do? I'll do the summation. My summation will be nothing but 16. The total number of elements that I have in n is 4. So 16 divided by 4 will nothing be 4. So here you can, now let's see this. Okay, this is very much important. Here, you know that from the mean, the other elements are a little bit far. So that is the reason over here you can see the variance as 4. That basically means the elements that are present in this particular distribution is quite dispersed when compared to this specific distribution. So if you really want to measure the dispersion of the data in a specific distribution, variance can definitely be used in an amazing way. Okay, so here you can actually see the example. Here you are getting the variance as 1. Here you are getting the variance as 4, right? So this basically means that from the mean, if I consider from this particular mean in this particular distribution, the variance is a little bit, the dispersion is a little bit bigger when compared to the other one. Okay, so this is the basic example of this. Now here we have discussed with respect to population data. Now with respect to sample data, how this particular formula is going to change, that is what we are going to discuss. Now with respect to the sample data, the formula will change little bit in a different way. So suppose if I really want to consider with respect to sample data, the symbol that is used is S square. Okay, and here I am going to use summation of I is equal to 1 to small n x of I minus mu. Instead of writing mu, here I'll write x bar, because in sample, if I really want to calculate the sample mean is given by x bar. Okay, and this will basically be divided by small n. Now there is one minute change that I really want to do. Instead of writing small n, I will write n minus 1. Okay, now you may be thinking, Krish, why sudden change in this? Because over here you written capital N, here you have written minus n minus 1, right? Why? And this is what we are going to discuss in our next topic. Why do we divide our sample variance by n minus 1? This is very much important. It can also be a very important interview question. So I'm specifically making a separate video which we are going to discuss in the next topic. So yes, let's continue the next topic.